Can everyone see my screen?
Yeah.
Yes.
Good. What you see here is the distribution or breakout of scores for everyone's first attempt on the Module 2 assessment. There were 11 individuals that attempted. The minimum score was a 2.5, so that's basically half credit. There was a 5-point total possible, and the maximum value was 4.5, which is actually really respectable considering the number of questions and the complexity. The average score was 3.36. So that's let's see what that is. Roughly 3.36 divided by 5 possible, so almost a 70. Again, that's still fairly respectable considering the number of and complexity of questions. I'm going to go ahead and just capture a screenshot of this so we have a record of our of the column statistics. And let's just capture that for record. What we're going to do now is run an item analysis and take a look at the assessment items that pose the greatest challenge for the group. We'll go ahead and click here and then run item analysis. Should take just 20-30 seconds at the most. Oh, it's done. That was quick. So here we have our item analysis. According to the statistical algorithms, there were 9 easy questions and 14 medium questions. None were classified as hard questions. That's kind of interesting. Cannot calculate and poor questions were often cases where all students answered identically or in a similar fashion because they all knew the answers. So once again, the Blackboard scoring algorithms for statistical analysis don't really account for a mastery learning scenario. What I'd like to do is sort this column based on average scores so we can have a look to see which ones were the most problematic. Anything that was multiple choice that was worth half a point, a quarter of a point, that had an average score of a quarter of a point means everybody got it correct. So these are questions we really didn't have to worry about so much. Anything that was multiple answer that did not have a higher score than that, multiple answer were typically half a point each, I think. And then there were a number of extra credit, multiple choice and true false questions. But we'll start with the bottom here. I just want to go ahead and print this out. Make sure we get this for record, just very quickly. So let's have a quick look at our first multiple choice item. The average score was 0.8 of a point when the possible score was a quarter of a point. And the question reads, for a wired network to function properly, the following electrical criteria are required for stability and reliability: a proper ground, adequate voltage, potential fluctuation. When we say potential, we also mean voltage. The word potential is another word for voltage. When you say electrical potential, it's just another way of describing voltage. The voltage fluctuation, meaning up or down, plus or minus, that's what that means. Fluctuation is less than or equal to 1/10 of a volt. And most everybody answered this correctly. Was this an extra credit? This may have been an extra credit item, and most everybody got it correct. 2 people selected proper ground, but didn't select the other criteria or notice the other criteria, so they didn't choose all of these. So the correct answer is all of these. Any questions on this item? Is everybody with us? Can everybody see the screen?
Yes.
Yes.
Okay. All right. Just speak up when you're ready. If you have a question or a comment or a concern. Okay. The next item that posed a significant challenge. A technology professional must ensure local Wi-Fi can carry more data. So when we're talking about carrying more data with wireless, we're talking about radio electromagnetic signals or waves. So we want the Wi-Fi signal or waves, electromagnetic waves, to carry more data. Which criteria will achieve this result? Use of an 802.11. So Wi-Fi is 802.11. 802.3 is a different standard altogether that has nothing to do with wireless. Doesn't have to do with Wi-Fi. So that would be a bogus answer. Nobody fell for that. A fiber optic interface or medium with redundant rings, that would not have anything to do with Wi-Fi. That would be fiber optic. So this has to do with radio signals, and this has to do with fiber optic cables. Most everybody got this correct. So it's the 802.1 standard with a higher frequency and shorter wavelength. So the higher the frequency, the smaller the wavelengths. The greater the frequency, the smaller the wavelengths. You have to have shorter waves, shorter and shorter waves, to squeeze them into the same length of media. Any questions about this item before we move on?
No.
Okay, moving right along. A technology professional must ensure local Wi-Fi can carry data a greater distance. So this time we're talking about greater distance as opposed to a higher data rate. If we want Wi-Fi to carry a greater distance, which criteria will achieve this result? And most everyone selected the correct answer. An 801.211 standard with a lower frequency and longer wavelengths is the correct answer. Shorter wavelengths carry more data, but when they hit any kind of objects or interference between the transmission and reception site, they have a tendency to get blocked or distorted. So higher data signals don't travel as far through walls, through buildings, through trees, through vegetation, through clothing, through people, across water, etc. Right? 2 individuals chose the fiber optic answer again. That fiber optic strands, the glass strands that carry fiber optics, are not used for Wi-Fi. So that would not be a good choice for this. Any questions on this item before we continue?
No questions.
Okay. Moving right along. A new medium. It's multiple choice question. A new medium is discovered that allows a sampling rate of 100 million per second. 100 million cycles per second is what it should read. And can signal 64 bits with each sample. According to Nyquist's theorem, what is the theoretical data capacity for this new technology in bytes per second? The reason there are asterisks on either side of the word bytes is because when you're talking about sampling rates, you're talking about baud or waves per second, right? You're not talking about, we want to know bytes instead of bits, I guess, is the big deal here. So let's recast this. When you see asterisks on either side of the word bytes, remember that there are 8 bits in a byte. So the first thing we have to do is multiply this. It's a pretty simple process. We multiply 100 million times 64, and that gives us what? Let's look at it. Very large number. 100 million. And we're going to multiply it by 64. That's going to give us 6,400,000,000,000 bits. But we have to divide by 8 if we're going to get bytes. That's going to give us 800 megabits per second. So the word mega means million, and that's our answer. Okay. If you chose 6.4 gigabytes per second, you basically missed the conversion between bits and bytes, and you just counted bits as if they were bytes. And yes, there would be 6.4 gigabits per second, but that's not what the answer reads. It says bytes per second. So just remember that baud and bits are fairly equivalent. If you have a gigabaud per second or a gigabit per second, that's you got to divide by 8 to figure out what the true bandwidth is in bytes, in kilobytes or megabytes and gigabytes. And that's what threw people. This is a correct answer if we were asking for the number of bits. Oh, no, actually, it would need to say gigabits. Yeah, it says megabits, so that's not enough. And 6,400 bytes per second, that would be, not sure how you get that number 64, but it's just a bogus number. So very straightforward. Multiply the sample rate times the number of bits per sample. So 100 million samples per second times 64 bits per sample, and then divide by 8 if we're asking for bytes, or leave it the same if we're asking for bits. Any question on this item? Hearing none, we'll move right along.
Could you repeat what was the correct answer?
The correct answer was 800 megabytes per second. The correct answer was 800 megabytes per second, because we get 6.4 trillion bits per second, or gigabits per second, and you divide by 8 to get bytes. There are 8 bits in a byte. Okay. Any other questions before we move on?
No questions.
Okay, I think this was true, false, and it was extra credit. I believe everybody got it correct. I don't think we have a single incorrect answer. Yes. So FSO is free space optical. It's another word for optical wireless communications. This is the laser beam across the air we talked about in class. A great way to recover from a hurricane disaster where everybody's broadband is knocked out. You need to connect. You know, when the infrastructure of the island is destroyed, you can quickly reconstitute high bandwidth, high data rate backup systems using FSO or optical wireless, right? We should probably talk to some of our internet service providers about adopting some hurricane recovery kits using FSO or OWC. If they were the first to do this and recovered their service faster than anybody else, they'd put everybody else out of business for internet service. I'm saying that for the benefit of Nick, who is here today on a ladder installing my new broadband VI service connection. Can I ask everyone to unmute and applause for Nick today? He's a hardworking guy.
Good job, Nick.
Ah. Okay. And there's love in the house for you here, Nick. All right. And I don't know if you heard what we were just saying about disaster recovery and hurricanes and being able to quickly reconstitute. You can actually power these things with solar panels. Yeah. So broadband VI could be like the king of hearts and everybody else sucks wind, right? Literally sucks wind. Just saying. So if you ever want to talk it up, yeah, we could actually like sponsor some summer internships for some of our students to work with you on that. Yeah, demonstrate proof of concept, win-win. Yeah, paid internships, grant funded. Woo! Yeah, that'd be a nice idea. All right. Anyway, moving right along. Yeah, you got to make lemonade out of lemons, right? All right. So a broadcast. Here's the other one. This is another true/false extra credit question. I believe everybody got it correct. That's why you cannot calculate whether or not it was a good question or a bad question. The best questions are ones that everybody answers the same and the answer is correct. That's my opinion. Anyway, a broadcast domain, the word broadcast refers to the local area network created when network devices broadcast data using a MAC address to identify wireless or wired clients. Yep, that's a true statement. Nobody got it wrong. So glad. Hub versus switch. Now, this is one that took a lot of people by surprise. This is something we should have, or perhaps could have, called out more intentionally in our class. But in the assignment where you had some quick videos to watch when they explain the difference between hubs and switches, excuse me, yeah, that was my stomach growling, so I'm hungry. Anyway, multiple choice. Network switch is more advanced than a network hub. Select the choice below that summarizes the most important difference. So a hub sends data for all MAC addresses to all physical ports. It's just a giant multi-port repeater. So if somebody has a broadcast for a specific person or for everyone, it doesn't matter. Everybody gets it. It just repeats. That's what a hub does. A switch doesn't do that, right? So a switch says here, a switch sends data for all MAC addresses to all physical ports. That's an incorrect statement. An Ethernet switch only sends the data for the MAC address to which the frame is addressed. Remember, frames have a header that include the to and from identities of those clients. You know, this is from so-and-so, and I'm sending it to the gateway. I'm sending it to the server. I'm sending it to my girlfriend on her wireless network interface. A hub sends data for a given MAC address to only one physical port. That is the definition of a switch instead. So that statement is incorrect because it identified hub instead of switch. A switch broadcasts all frames to all devices on the broadcast domain except the origin to prevent loops. Now, that's a bogus answer, and I added that except for the origin to prevent loops, just because as you think about it, you're thinking, yeah, that makes sense. And but it's an incorrect answer, and it's an incorrect statement. The first part of this is the part that's incorrect. All frames to devices on the broadcast domain. That is almost the same as this other statement about the switch sending to all. Now, when hackers try to overcome a switch, the switch was an advancement and a security, well, it was both a performance improvement and a security improvement because it sends only to the MAC address on a specific physical port, as opposed to repeating the same frame to every port, every client. So a switch was a dramatic improvement in terms of performance and in terms of security, because not everybody's getting everybody's Kool-Aid, right? The thing that I want you to understand is that hackers have this method where they blast a switch and they flood a port with too many frames of data. They kind of jam it into there, and it causes the switch to hiccup. It almost puts it into a coma in a manner of speaking. And when the switch goes into a digital coma, it reverts back to the behavior of a hub. And then it's like it rolls over and goes unconscious. It can't do its job because it's too flooded. So hackers try to push too much data on a port deliberately, very high rate of speed. They kind of jam it up. That's called port flooding. It's a massive attack. And if it's successful, the switch will revert back to its primitive mode as a hub. And it doesn't try to think. It's like, oh crap, there's too much. I can't sort this out. I'm just going to send it to everybody. And it just sends it to everybody. And
So what happens with a broadcast?
what happens with a broadcast? That's a great question. So on the broadcast domain, another thing that happens is that everybody else's client is also flooded with too much traffic. So one of the most important symptoms that you'll encounter is that everything is just slow for everybody. They can't browse, they can't click, they can't get anywhere. It's like, holy crap, what's going on here? And then once the hub flips back into its native mode, the hacker stops the attack. Because now that switch is in hub mode, it's in primitive mode, and the hacker wants everybody to think, oh, thank God that bottleneck passed. Now we have service again. Except that the hacker is slurping up everybody's stuff. He or she is getting a copy of everybody's data. So in terms of the broadcast and the network itself, users experience this tremendous, everything just bogs down. And then all of a sudden it's clear.
No, I was asking about a broadcast frame that it sends out to all the ports.
Oh, what happens to
Wouldn't
that?
it send it to all? Wouldn't it send it to all the devices except for the
No,
device?
no, it tries to overwhelm a single port by overloading it, and that resets the whole switch. So to answer your question, it doesn't send a flood of broadcast packets. It targets a specific port on the switch. And because on a switch, you can set up different levels of security. So a hacker is going to run down the switch, down the line of ports, and it's going to try to flood different clients with that huge volume of data in the hopes that one of those ports doesn't have as good a security criteria set up. So that's what happens. We'll talk more about this when we get to layer 3 in the next module. So it's a good question. Glad you asked it. I don't know if I answered it completely. Did the detail I provided help?
Kind of. I was still thinking about the broadcast frame, like instead of having intended MAC address, it's all Fs. So it doesn't know which
Right.
MAC address. So it broadcasts to all frames. So you said that it will only go out to the ports that.
Well,
yeah, I was trying to.
so a hacker can do things to deny service to everyone. And what you're describing is a useful method for denying service to everyone, because you're flooding all of the ports, all of them simultaneously, and it just crashes everyone.
Okay.
But what typically happens when a hacker is trying to break onto a switch and send it back into hub mode is that it's flooding a specific port to overload the memory buffers and to overwhelm the processor and the switch, and then choke it. And then once that happens, the switch ends up back in hub mode or primitive mode. And at that point, see, if a hacker uses the broadcast address with all Fs, all ones, and that's what you're talking about, then the intent is to so overwhelm every client that's connected that they can't send or receive anything. And that's a denial of service method, right? But it doesn't let a hacker sniff the frames that are coming from each of the clients. It just bogs up everything and nobody can do anything. And eventually the network logs are going to point back to that hacker, and that's not a really good method. Yeah. No, that's okay. Yeah, do what you got to do. So Nick was just saying he's got to punch through some concrete. Are you going to go from this side?
Yeah, you want it, which one you want?
You want to come outside in, right near the, right below the hole that's already there?
I'll go inside of it, below the wall. I don't want it to break on the inside. The concrete's on the.
Oh yeah? Okay. Well, can you get back in there? All right. Yeah. Don't be afraid to move some things around. Like you can slide that little thing out. All right. Let's move on with the other questions with the time remaining. And let's see. High-speed data as a distance, multiple choice. You must connect two digital components separated by 20 miles. We did say that serial or parallel transmissions are typically handled between digital components within the same system. If you have a 20-mile distance, you're not talking about connecting for digital communication purposes two different components within the same server or the same workstation. If they're separated by 20 miles, that's between systems, not within a system. So serial transmission is the only way to go. That means you're eliminating the parallel transmission item, because 64-bit input output, there's lots of parallel transmission that happens, but only across the data bus on a motherboard within that system. And it's not a 20-mile distance. So when we talk about serial transmission, they can send and receive data using the keyword there is same. They can send and receive simultaneously with the same high-speed data rates. What we're talking about there is synchronous as opposed to asynchronous. So a serial answer that talks about synchronous would be the answer we're looking for. If you talk about a serial answer that has a half duplex transmission configured, that means it can only send and only receive one at a time. So it's not doing both at the same time. If we talk about 4G streaming with asynchronous, that's cellular. That's not the same as what 4G has to do with cellular transmissions. It's not the yeah, you wouldn't use cellular traffic. So and asynchronous means they're not the same data rate, they're different data rates for send and receive. So this is wrong on a couple of points. It talks about 4G, which really doesn't have to do with standard data transmission. It has to do with cellular service. But the keyword, the real thing that tips the scale here is the word asynchronous. So this is the only one that matters right here. The fact that we talk about a specific speed, it's not a showstopper. This is the best answer. Any questions about this? Okay, I'm going to mute for a second so that Nick can knock away with the hammer drill. So we're going to take like a 90-second break, all right?
Okay.
All right, so everybody stand by. Take it away, Nick. Okay, so let's continue with the time remaining with the rest of the questions. So whenever you have a long distance, the preferred method of transmission is a serial transmission method as opposed to a parallel transmission method. And synchronous means that they have the same data rates sending and receiving, right? Send and receive data rates are the same. That's the key to remembering that anything that says asynchronous doesn't work. Yeah. All right, moving right along. Multiple answer, and this was a very low score for a multiple answer that was worth a half a point. So wireless router components. Select the items below that represent the common network components and or functions found in a consumer wireless router. For example, Netgear, Linksys, TP-Link, Motorola, Asus, and so on. A switch, a router, and a Wi-Fi repeater. So that Wi-Fi radio or repeater, the thing I want you to understand is that Wi-Fi is just like a hub. Wi-Fi is a hub, only through the air. Wi-Fi behaves the same as a hub, not a switch, which means everybody gets a copy of anything that's sent or received. Let's say that again. With Wi-Fi, everybody gets a copy of what's sent or received. So you have like this repeater, a wireless repeater, you have a router with a gateway out to the internet, and you have a switch with the ports, the LAN ports in the back. In between the internet and the local area network is a gateway. There's often DHCP functionality and network address translation. So the public network address is converted to a local private non-routable network address range. We had a few, a multi-homed MAC address, modulator, demodulator, and multiplexer. That was a bogus answer. Modulator, demodulator is a fancy term that means modem. There are not, we don't have a modem that's built into the average wireless router that a consumer would purchase. You might have a cable modem, but it would not include multiplexing, and it would not involve a multi-homed MAC address. The device is multi-homed. A specific MAC address is not multi-homed. Let's repeat that. So a MAC address itself is not multi-homed. A device, a system, an appliance, a wireless router can have more than one MAC address that's active. When you have more than one network interface with more than one MAC address active at the same time, that's referred to as a multi-homed system or a multi-homed device. But MAC addresses themselves are not multi-homed. A wireless 4G LTE bridge, that means we're dealing with the cellular service, not Wi-Fi. And firewall with NAT and a DMZ portal. Some selected this, but the kicker there is whenever we talk about 4G and LTE, we're not talking about Wi-Fi or home wireless. We're talking about phone service, cellular phone service. So those are always going to be bogus distinctions that you want to watch out for. And yes, cellular can be considered a type of wireless, but it's a different standard altogether. Consumer wireless that we call Wi-Fi is 802.11. Cellular standard is something totally different. So cellular service and Wi-Fi service are not the same thing, even though a lot of smartphones allow you to do both at the same time. Multi-homing your smartphone, which can be a security problem, and this is one reason why a lot of smartphones get hacked. Anyway, any questions about this multi-answer item before we continue?
No questions.
No questions.
Okay. All right then. A common wiring error. So this is another troublesome question for multiple choice. Yeah, there were a number of folks that selected the So what is a common mistake that inexperienced technical staff make when wiring Ethernet connections? Well, if they're inexperienced, it's not like they would deliberately put 568A on one end and 568B on the other end. The only reason that a wiring tech would do that is to create what's called a crossover cable. And that's, so I guess that could be a mistake, but that wouldn't keep you from communicating, because most network equipment nowadays does something called auto sensing. So it can tell whether or not you're connecting equipment to equipment or network equipment to clients. One of the biggest mistakes they make is that they use solid Cat5 cable for patch cords when connecting client devices. Client devices move around. So when you're connecting a printer, a game console, a laptop, a workstation, a gaming network, PC, consumer devices and systems are moved around a lot on different, to different furniture and stuff like that. Whenever you're hooking those up, you're supposed to be using stranded cable, not solid. Stranded tends to be a little more expensive, and when people go to the hardware store, they buy solid, and that solid stuff is designed to go in the wall where it's strapped down into hardware and cable management brackets, so it never moves. And that's one of the most common mistakes that's used for the wiring of Ethernet connections. Any questions about this item?
No questions.
Okay. Next question. Multiple choice. Most everyone got this correct. There were a few that didn't know that basically modulation, demodulation, which is performed by a digital signal processor. Some students selected the incorrect answer that read modulation, demodulation performed by frequency division multiplexing. Okay, so multiplexing is a different thing altogether. Any of the terms associated with multiplexing would have nothing to do with modulation. It's a trick question. So it's like me saying, okay, what type of fish do you want to catch when you go fishing this weekend? And you say orange, no, blue, right? So if we're talking multiplexing, that's a totally different thing. It's like talking about colors. And modulation and demodulation is a different way of stuffing more data into a signal. Now, multiplexing can be used to enhance modulation and often is used to squeeze more data capacity out of modulation. So you can combine the two, but they're technically different concepts that are uniquely distinct from each other, and the way they work is unique and distinct and not similar in that manner. And yeah, so what I did was I used an adjective that has to do with multiplexing and included that as an answer for modulation. And if I had said something like FM or AM here, then that would have been good. But I didn't. I chose something that had to do with multiplexing, right? All right, any questions? Okay, let's see if we can move a little faster to multi-answer questions. We're going to focus the remaining time we have, the next 2 to 3 minutes, on multi-answer questions with low scores, because these multiple choices were nearly correct. Star topology essentials. Select the answers below that are accurate about a star topology. The total distance allowed for a simple star topology is roughly 600 feet. If you can go 300 feet and then you have a leg of the starfish that's on the other side of the starfish, that's another 300 feet. So the total distance is 600 feet. I need to explain that again. With a star topology, you have legs that come out from the center switch or hub, and it looks like a star or a starfish, right? So if you have a 300 length run here, and on the opposite side, you have another port that runs 300 feet there, the total distance from one side to the other that you can have would be a 600-foot distance total. And that's why that answer is important. Okay, what's the max distance you can stretch with a single switch? 600 feet. Because if you go in any other direction, that's at a diagonal and you're not traveling as great a distance as you would in a straight line. It has to do with geometry. Does anyone want to see like a drawing to explain that, or were the motions I was doing with the mouse sufficient? We can start the class on Wednesday by explaining that a little further if anyone would like. Just remember to ask on Wednesday. It is more resilient since a client failure does not disrupt other clients. That's one advantage of the star topology over the bus topology or the ring topology, unless the ring topology includes multiple rings running in redundant opposite directions, and that's done sometimes. A star topology can be linked to another star to overcome distance. Here it says a star topology connects each client to a neighbor and then to the switch. No, if you're connecting to another neighbor, that's bus. Star topology results in a multi-homed device that can loop and crash a network. No, it doesn't. In fact, a star topology helps reduce the possibility of a loop. But one thing you don't want to do is have two network cards on a single system and then loop them together on the same switch. And I mean, I'm not sure why you would connect two network cards to the same switch for the same reason. That's just goofy. You would want to team them. You would want to team them together and not loop them. So anyway, that's not a good answer right here. Any questions about this multiple answer item?
No questions.
Okay. Bus topology. There was another challenge with this one. So here with bus topology, select the answers below that are accurate about the bus. A bus connects each client to its neighbors and then to the switch finally. Right? A connection distance between the devices can exceed 300 feet. That's because they're all chained together. So you have 300 feet to the next device, 300 feet to the next device, 300 feet to the following device. As long as you keep connecting, you're adding 300, 300, 300 feet. A disruption of one client can disconnect other connected clients. In fact, if it's close enough to one end and most of the rest of the end follows, then most of the clients can't connect after that's severed. So that's a big problem. The two false answers were the bus topology is the most common form of wired Ethernet in use today. It used to be when wired Ethernet first came about, they had something called base 2 instead of base 10 or base 100 data connections. That's because you connected two devices to two devices to two devices and chained them all together. A device using a bus topology must have a token to communicate. That's incorrect. A token ring is physically a bus topology, but it's a logical ring topology. That's a special case, and that's not the common. It's not the common implementation for a bus topology. So that's a bogus answer. Any questions about this item? Okay, we've got time for one last question, and then we'll open the floor to anyone who wants to cover something in multiple choice. These all look good. I think we're good. Does anyone else care to cover another question before we clear for the day? All right, hearing none, I'll put the reconciliation out on Blackboard. Please reconcile before our class on Wednesday. I'll start posting alternate versions for Module 1 and for Module 2. So you can start taking your second attempt at the module assessments by Wednesday. And then we want to give you time to take the midterm exam at that point. We also extended the time you had to complete your Module 2 solution in case you needed additional time. If anyone has any problems with the Module 2 solution, does everyone know that we have the videos in place now? Inside the resources folder, you should see solution tasks. And then we have 3 related videos that walk through update of Wi-Fi router firmware, enhancing wireless router security, and identifying the public address and contacts for additional support. Anybody else? Anyone have any questions before we clear? Going once,
No questions.
Questions?
going twice. Have a good day. We'll stop recording. See you Wednesday. Good luck on your second attempt.
Dr. Gonzalez.